And how would I write this prime factorization, Sophie?
2 to the second times 5.
2 to the second times 5. How would I write the second? Tristan?
2 to the second times 3.
Good. 2 to the second times 3. All right. And with LCM, least common multiple, what am I going to use from these two prime factorizations? So you're thinking either GCF, we did this, or LCM, we're going to do this. Yes, ma'am? The greatest number of times each factor is used. So what about the 2? How many times are we going to use 2? 2 times. So 2 to the second. Anything else? Times 3 times 5. Now, do you have to multiply it in this order?
Yeah. No.
Or can you multiply it backwards? Or can you mix them around and multiply? Yeah, so it doesn't matter the order, whatever you prefer. But you do have to do something first because of order of operations. You must do this first.
Exponent.
What's 2 to the second again? Okay, so now you can pick. Personally, I would do 4 times 5, 20 times 3. All of us should get 60. Whatever you multiply, whatever order, you should get 60. Okay, now I'm going to give you a problem, see if you guys can do it, and I need you to do prime factorization. So, Mr. A, do we have to do this for all these problems for today? You do. And then for your quiz, your test, which comes up on Monday. That's next Monday. That's not today. I wouldn't do that to you. Well, no, I wouldn't do that to you. This is next Monday. You'll have a test over chapter 4. So that's coming up next week. Yes?
How do you know, for that problem, how do you know how to get, how would you know, which numbers to divide first to get a certain number?
So, after you do the prime factorization? Or...
You said 4 times 5 first and then 20 times 3. How would you know which way?
I would just say, what I try to do is I try to get, when I multiply any two of them, I try to get something that ends with 0. So isn't 4 times 5 going to be 20? And that's nice to multiply by 3 because 20 times 3 is 60. I could do that quicker in my head. But you could do 4 times 3 is 12, and if you know your 12 times 5, you'll get 60. So either way, you'll get it. Or 5 times 3, 15 times 4, 60. So it doesn't matter how you do it. Yes, sir.
So, you said we need to do prime factorization. Can we do it on our head and write it down?
You can, but as long as you write this down. Yeah, I see what you're saying. Yep. So you can go from 20 to this, 12 to that, then use it to get your answer. All right. I need you guys to try out number 20 on that same page. Please do the prime factorization. You're like, Mr. I already know it. Good. You need to prove it with your prime factorization and see if your method works out.
Which one? 2 and 3.
Same page, number 20. And I'll do this. I'll call a couple volunteers just to write out the prime factorization. You don't have to tell me how you did it, but just tell me this is the prime factorization. You can come and write up on the board. And you can bring your notebook if you need to. Both. How about that? You can do both. And use either marker. Yeah, it's a different color now. It's been upgraded. He'll do both, and then I'll have another example. Yes.
It looks like a weird yellow.
I have another word to describe it. I'm not going to use it, but yeah, it's kind of a nasty looking yellow. Okay, so this one's nice. 3 times 5 is 3 times 5. And then how would I write this prime factorization? 3 times 5 squared. So he carries down that 3 all the way down. Okay, did you guys get those? Okay, so how many times am I going to use 3, Michael? Once. How many times am I going to use 5, Emma Grace? Twice.
But there's only 1 5 here. But you use 2.
You use it the most number of times it's used in any one of these numbers. So, yeah, twice. And that's something you got to remember. Josie, anything else I want to use? No? Okay, so we're going to do really 3 times 25, which was 70. Wait, that was how can that, okay. Is 75 a multiple of 75?
Yes.
Is 75 a multiple of 15?
Yes.
Uh-huh. Is that the least common multiple between the two?
Not
And the
necessarily.
Yes.
okay, other than 0. And remember, when we say LCM, we're saying not 0. Because, 0 would always be it. Good. Thank you for reminding us of that. Okay, I want to see if you guys can do a tough one. Number 22. This is all on you guys. Number 22. Can you do it? Find the LCM of 24 and 32. And again, use prime factorization to do it. Okay, I'm going to call a couple people up here. Caroline, can you do 24? And Braden, can you do 32? In just a moment, let her do that. Actually, there's a cool way, I think. Sorry, Caroline, I'm going to do one little thing. There's a cool way to make it split up. And now you both, if I can get it to work, please let me go up. Yes. Oh, okay, it won't do it. I got to look at it. But I can make them where you can both write at the same time. But unfortunately, not right now. That's good. Okay. And then I'm going to call on Elizabeth to tell me the prime factorization that I'm going, or the prime factors that I'm going to use to get the LCM. Mm-hmm. Yeah, you're good. And then, who was the second one? Braden? Come on up, please. You do 32. And then Elizabeth's going to tell us which prime factors we're going to use and how many times. And then I'll have Sydney tell me how she wanted to multiply them. So you're just going to tell me your method. Oh, okay. And then can you write the prime factorization in order with the correct exponents? Super close. No. There we go. Okay. So Elizabeth, how many times am I going to use each number?
You're going to use 2 6 times and 3 once.
Let me make sure here.
2 5.
5 times. Good. 5 times. And then how many times am I going to use 3? Once. Okay. So what did you do here, Sydney? I don't get it.
Since I knew that 2 was 32 because
Yeah, and that happens, by the way. You know what's cool? You're going to be like, oh, man, now I got to find out what 2 times 2 times. You already figured that out. So it's up to 32. And then go ahead.
And then I just multiplied 32 times 3 and I got 96.
All right, so how many of you got 96 as your LCM? Okay. Do you guys remember how to do it with variables? It's the same thing, same process, except now you're dealing with variables. So do 26, and we'll be done with that part. And then I'll finish up with LCD. So number 26 on that same page, find the LCM of 20CD and 50D. Yes. Okay, I'll have John do 20 CD. You're going to break it down whenever you're ready. You can come on up. And then I'll have Emma Grace do 50 D. Michael will tell me which factors are going to be used how many times. And Tristan will tell me how he multiplied, or what he got at the very end. Okay, and then write it in prime factorization form. And there's a little bit more, just a little bit more there. So you got the numerical part. There you go. Okay, thank you. And Emma Grace to 50D. So right now what we're doing up on the board, what you are doing on the board as you volunteer or are volunteered, is basically you're doing what you did on your quiz, isn't it? And some of the same things that happen on the quiz are happening up here, and I'll point those out in just a moment. Okay, and then Michael, which factors are you going to use and how many times? Two's going to be twice? 5 twice. Okay, and Tristan, what are you gonna do here?
So you do 2 to the second, which is 4, and then you do 5 to the second, which is 25. So 100 CD.
You should get 100 CD. It is a big number. It's not that big. Okay, now 100 CD is the smallest common multiple that 20 CD and 50D share. So they can both fit into that number evenly, and that's the smallest one. How many numbers, by the way, can they fit into? How many numbers can those two original numbers fit into? Do you remember? Sorry? Infinite number. This is the smallest one. So this one's going to be useful because we're getting into this last part, LCD. And we kind of talked about it, but I want to make sure you guys understand what they're asking for when they look for least common denominator. I love these names, by the way, don't you? Like denominator, numerator, terminator, right? So let's do a famous scene from the Terminator, this time with math. Ready? Oh wait, I gotta start this way. I'll be back. Yeah. I am the denominator. No. Right? Cringe. Denominator? No? Should I use numerator? Is that better? Okay. Thank you guys. Least common denominator, LCD. I hope it's not too tricky, but here's a problem you would get. If you're looking in your book on page 203, look at the directions for 33 to 40. 33 to 40.
For what?
What are the directions? Find the least common denominator, LCD, for each set of fractions. So if I do let's do number 36. So I'm going to look at number 36, and they give me two fractions. 2 ninths and 5 twelfths. By the way, guys, on that scene, he had glasses on, so it's like he can totally look a lot more imposing than I was, because I'm wearing this. Okay, he was wearing a leather jacket, sunglasses, and it was at night. So come on, give me some credit on that.
You should have turned off the lights.
Oh, okay. The denominator is coming out. Denominator 1 and 2. Okay, anyway. Here are my two fractions, and I want to find the LCD. And you're like, so what do? All they want you to do is look at the denominators, okay, 9 and 12, and find the LCM of those. So can you find the LCM of 9 and 12?
Yes.
Yeah, and
36.
okay, so here you would get 3 squared. And here you would get 2 squared times 3. So how many times am I going to use 2? How many times am I going to use 3? So 4 times 9 is 36. So what's the LCD? 36. That's all they wanted. That's all they wanted. On 33 to 40. And see, here's all they wanted on that problem. Look at 33 through 40. It says find the LCD for each set of fractions. So for number 36, my answer would be, in this case, 36. So that's all I put. They don't want anything else. Look at 41 to 48. It says replace each blank with less than, greater than, or equal to make each statement true, or to make a true statement. So in that case, we're going to do what we're doing here on this next example. I'll go with example 3. We did this one already. Well, let's go with number 42. I think we already did example 3. So look at number 42 in your homework. Okay, they want me to compare 3/5 and 4/7. And there's a blank. All right, so in order to compare these properly, because you can guess, right? You have a 1 in 3 probability of getting it right. You can say greater than, less than, or equal to, and you can get it right. But we want to get them right every time. We don't want to guess. So what I'm going to do is I'm going to find the LCD of 5 and 7. And this one I hope you can do pretty quickly. What's the LCM of 5 and 7?
35.
Okay, so here I'm going to put the least common denominator is 35, right? That's the LCD, which means the least common multiple of the denominators. Okay, and this is something I want you to do and do it well. I want to change this denominator to 35. So what should I multiply the fraction by? Let's see if you remember what we talked about on Friday. I'll go with Callie. What should I multiply 3/5 by to get a denominator of 35?
By 7 over 7.
Oh, my heart almost stopped there. 7 over 7. Why not just 7? I mean, you can just say 7. Okay, ready? 3/5 times 7 is a number. 3/5 times, what's this actually mean? 1. It's just 3/5 in a different form. So you're going to say it properly and you're going to write it properly because I want you to understand it properly. Okay, so what property is that, by the way? What property is that when you multiply by 1? Tristan? Identity. So did we keep the identity when we multiply by 1? Of course we do. So what is this right here?
21 over 35.
So now I have a denominator 35. What should I multiply the other fraction by, Emma Grace?
5 over
5 over 5. And what's that going to give me, everyone?
20 over 35.
20 over 35. Now, to show you what this problem actually means, you remember 3/5 and 4/7? They're very close in value. They are 1/35 difference between the two. 1/35. So if you had a pie, you guys like pies, and you cut it into 35 parts, equal parts, 1/35 is the difference between these two. That's not much. And so now what's the comparison symbol? Greater than. And that's all I'm going to want on that problem. I want work, though. I want this to show me that.
And if you simplify it, you get 3 over 5 and 4 over 7.
Very good. It goes back and forth there. Good. Very good. Any questions on that? Yes, sir.
So, I know in this one you multiply by the denominators because
They're the-
that's the least.
Do you know why, though? Why would you multiply in this case? This is a good quote. Why did you just have to multiply those two together?
Because left or else they don't have anything smaller than that.
Yeah. What's the prime factorization of 5? 5. What's the prime factorization of 7? So they're both prime numbers. You can multiply them together.
And
That's
so,
nice.
couldn't you just do that even if there was a small one, so you wouldn't have to do the LCM?
Well,
Just
you.
to save you time?
So yes, you could, but to save you time, I would say that probably won't happen. Let's say, for example, that problem we just did together, number 22. If you had denominators of 24 and 32, you could multiply them together. It's going to be a big number, and then you're going to have to simplify it anyway. If you use the LCM, it's going to make your simplification process easier. Yeah, so that's true. Good thoughts. Okay, your homework tonight. Oh, my. Oh, any questions, guys? Are you guys getting this? Please read the instructions to know what they're asking you to do. And you're doing 19 to 49 odd.
Why don't we do the even one?
You want to do the evens too?
No. You can check them in your bag.
Yeah, you can see if you're doing them well, and then it'll still give you a good amount of problems. So, just a reminder, guys, if you're using the answers in the back, that's okay. That's a good thing, as long as you use it the right way. So, basically, this is what I notice people doing, and I haven't seen it here, but I hope I don't see in the future. So, I'm giving you time to do your work, and this is what I see. You have your pencil. This is we're gonna pretend, and you're doing this. Okay, you might get some answers right on your homework, which is worth very little of your grade, and then when it comes to that quiz and test, you don't know what you're doing. So it's going to come back and it's going to affect you now or later.
You can figure it out because they'll probably just put the answer.
Yes, exactly. Okay, thank you.